Hello, welcome everybody in the lesson of today. As usual, this is a mathematics as a subject, and this lesson is designed for year 1 science and mathematics education. School is a TTC Training College, TTC. I'm Felix Kajayesu. Welcome all. This is unit number 4, which is called linear and quadratic equations and inequalities. The lesson of today is called solving quadratic inequalities. As the target of today, the main objective, the objective of today, having background on solving quadratic equation. By the end of this lesson, every participant will be able to solve any given quadratic inequality successfully. So, to solve the inequalities of the form of ax squared plus bx plus c less than 0, or ax squared plus bx plus c less than or equal to 0, where a is different from 0, we find all real numbers that make the left hand side to be negative. To solve the inequalities of the form ax squared plus bx plus c greater than 0, or ax squared plus bx plus c greater than or equal to 0, where a is different from 0, we find out all real numbers that make the left hand side positive. There are two ways of solving quadratic inequalities. The first one is using the table of sign and using compound inequality. But for the lesson of today, we are going to focus only on using the table of signs, where we have 4 steps to follow. The first step is to solve the given in ax squared plus bx plus c equal to 0, and the main objective here is to factorize the given quadratic parts. Secondly, we write ax squared plus bx plus c in a factorized form. Then next we construct the table of sign by finding the sign of each factor. Then finally we multiply or we divide accordingly the signs which are found in the table of sign. Here we have to notice that for the quotient, the value that makes the denominator to be equal to 0 is not always in a solution. It is not a solution. For the value, that value we use the symbol which is here in the row of quotient sign. Then finally, the last step is to write the solution set. Means that we write the interval considering the given inequality sign. Dear friends, here we have an example. We are going to solve together the given inequality x squared minus 5x plus 6 greater than or equal to 0. Here, as we said before, we have to factorize x squared minus 5x plus 6. And you remember that there are many ways to factorize a given function or polynomial. Here you can use delta You can use grouping or the other ways that you know. In this case, we try to use any way, and then we find the value of x. Means that as you have x square, we have to get two values of x. If we use any way for your choice, we will get that x will be equal to 3 or x will be equal to 2, and then write x square minus 5x plus 5 in a factorized form. Means that it will be equal to x square x minus 2 times x minus 3. The important part that is going to follow is to make the table of sign. In the table of sign, in the table of sign, first of all, we have to, in the first row, we put the values of x, which are varying from minus infinity up to positive infinity. We are going to locate the number of values of x that we get before, and we start from the smallest to the highest, to the largest. It means 2 comes first and 3 comes next. In the first column, we put the factors that we found when we were factorizing the x square minus 5x plus 6. Then we start by x minus 2, then x minus 3. You can start even from x minus 3 on your choice. Then x minus 2 comes next. Then we will have on the last row x square minus 5x plus 6, which is the product of the two factors given above. And then for x minus 2 in this row, we ask ourselves, if x is equal to 2, this x minus 2, if we replace x by 2, we'll have x minus 2, that we will get 0. And that 0, we write it in the second row under the value 2. Means that for number 2, the value of x when it is 2, x minus 2 will be equal to 0. We do the same for x minus 3. We continue, and if we replace x by 3, we'll see that x minus 3 will be equal to 0 when x is equal to 3. And then we go to the last row. If x is equal to 2, x square minus 5x plus 6 will be equal to 0. Because 2 is a solution, or it is a root of x square minus 5x plus 6 when equals to 0. The same for 3 also. If x is equal to 3x square minus 5x plus 6 will be equal to 0. Then we are going to put the sign. I want from you to be very attentive. For x minus 2, in the interval from minus infinity up to positive 2, we are going to look for, to choose any number between that interval minus infinity up to 2. Then we replace that value in x minus 2. Dear friends, let us take for example 0. 0, it is in the range between minus infinity up to 2. If we replace x in by 0, we'll have 0 minus 2, and then the answer will be minus 2. That sign of the answer means minus 2. The minus which is followed by 2 is the one that to be put in the interval between minus infinity and 2. And we look for the sign which is between 2 and minus and plus infinity. It means 2 in between 2 and 3 and plus infinity. We choose any number between 2 and positive infinity. Also we place it in the same factor, which is x minus 2. For example, let us take 3 or take 5 or take 10. For your choice, you can take any number that you want. If you take, for example, 5, you will take 5 minus 2 and then you get 3. If you take 3, you will replace by x, then you take 3 minus 2, then you get 1. If you take 20 minus 2, you will get 18. And you can now see that always in this case we get the answers which are positive. That is why in the range between 2 and plus infinity we put positive 2. We do the same for x minus 3. It means in between minus infinity and 2 we have put negative, and from 2 up to positive infinity the sign, the x plus 2 is positive. For x minus 3 we are going to choose any number in the range between minus infinity to 3. And remember that we have not to choose minus infinity or 3. Means that we can even take 0, you can take 1, you can take negative 1, negative 3, negative 1, so that that number must be in the range between minus infinity to 3 exclusive. For example, if we choose 1 minus 3 we get minus 2. If we choose 0 minus 3 we get minus 3. And the sign that the answer has is the one to put in that range. You can see that we have negative answers. Means that from minus infinity to positive 3 we will have negative signs. That is why you have negative signs, you can see. From positive 3 up to positive infinity, we choose any number as we did for the previous factor. Means that we choose any number between 3 and positive infinity exclusive. For example, you can choose 5, you can choose 4, you can choose 10, and so on. If we choose 5 minus 3 we will get 2. If we choose 10 minus 3 we get positive 7. And that you can understand that the answers that we found, they are all positive. That is why in the interval between plus 3 up to positive infinity we will have positive. After getting the signs for the two factors x minus 2 and x minus 3, we will now find the signs for their product, which is x square minus 5x plus 6. Remember that in the previously we saw that the factorized form of x square minus 5x plus 6 is equal to x minus 2 x times x minus 3. Even you can replace x square minus 5 plus 6 by x minus 2 times x minus 3. In that case, we can see that x square minus 5x plus 6, it is the product of x minus 2 times x minus 3. In this way, as the x square minus 5x plus 6 is equal to the product of the two factors, also the sign for x square minus 5x plus 6 will be in each interval, it will be the product of the signs of the two factors respectively. Remember that here you can see that we have three intervals from minus infinity up to 2, from 2 up to 3, and from 3 up to positive infinity. Means that this x square minus 5x plus 6 will have also three intervals by their respective signs. Let us go on. If we take negative times negative, negative for x minus 2 times negative for x minus 3, we are in the interval from minus infinity up to 2. Minus times minus we get positive. From 2 up to 3, we will have the product of positive for x minus 2 and negative for x minus 3. The product of plus and minus will have minus. In the interval from positive 3 up to positive infinity, we have plus times plus, that will get plus. For until now, having the signs of x square minus 5x plus 6, we can know where it is positive and negative, means that you can know where it is less than 0, greater than 0, and even equals to 0. Where you have 0 for in the law of x square minus 5x plus 6, where you have 0, it means this x square minus 5x at plus 6 at these values, it is equal to 0. And where you have positive signs, means that this x square minus 5x plus 6 is positive, means that it is greater than 0. And where it have negative signs, it is less than 0. And now finally, we are about the end. We have to write the solution set, which is the final step of solving. In this case, remember that the question was to solve x square minus 5x plus 6 greater than or equal to 0. Means that we'll find where x square minus 5x plus 6 is positive, is greater than 0, as we saw previously. In this case, we will see that x square minus 5x plus 6 is positive in the interval from minus infinity up to 2, and from 3 up to positive infinity. And in this case, when we are writing the solution set, always minus infinity and positive infinity, they are not included in the solution set, because minus infinity and positive infinity, remember that they are not real numbers. And because in the question we have given x square minus 5x plus 6 greater than or equal, this, when you have this or equal, means that those real numbers 2 and 3, they will be included in the solution set. Be attentive. So finally, as the final answer in the solution set, you can see that the solution set will be from minus infinity excluded up to positive included, union from 3 included up to positive infinity excluded. This was the first example. Now let us see the second example. In the second example, we have given 3x squared plus x minus 14, which is less than 0. You have to solve. As usual, we are going to start by factorizing 3x squared plus x minus 14, and we start by solving them, finding the values which can make 3x squared plus x minus 14 equals to 0. And if you use any way in your choice, by using determinant, which is the quadratic formula, by using grouping, by using sum and product, and the other ways that you know for your choice, we'll find that x1 will be equal to minus 7 over 3, or x is equal to 2. And finally, we can write this 3x squared plus x minus 14 in a factorized form. Finally, you can see how you know how to write in a factorized form a given polynomial, a given function. In this case, we will have x minus x plus 7 over 3 times x minus 2, which is equivalent, or which is equal to 3x plus 7 times x minus 2. We are going to do the same as we did for the first example. The first law is the values of x. That is why we write x. And the values of x will varies from minus infinity up to positive infinity. Means from the smallest number up to the largest number. And then we put the values of x that we found by starting from the smallest and then up to the largest. Then under x in the first column, we put the factors that we found in factorizing the given 3x squared plus x minus 14. We start by 3x plus 7. It does no matter, even you can start by x minus 2 as I said. And then we look for if x is equal to minus 7 over 3. If you replace x by minus 7 over 3 in 3x plus 7, you will get that it is equal to 0. That is why you write this 0. And when x is equal to 2, x minus 2 will be equal to 0. And when x is equal to minus 7 over 3, 3x squared plus x minus 14 will be equal to 0. If you want, you can replace x by minus 7 over 3, or x is equal to 2. In 3x squared plus x minus 14, you will find that it will give you 0. And next, we are going to put the signs. We do the same. For the law of, or the signs for 3x plus 7, we choose any number between minus infinity and minus 7 over 3 excluded. For example, you can even replace x by minus 3. That is the number in between which is belonging in the range from minus infinity up to minus 7 over 3. You will get 9 plus 2 minus 9 plus 7, which is equal to minus 2. And we can now have the sign for the answer that is equal to negative. And that is that negative that we put in the range of minus infinity up to minus 7 over 3. And then we see the signs which of 3x plus 7 in the range from minus 7 over 3 up to positive infinity, and we take a number in this range also. We do the same as we did for the first interval. In this case, you can even take any number for your choice. You can even take 0. If you replace 0 in 3x plus 7, the answer will be 3 times 0 plus 7, which will be equal to 7. And 7 is positive. That is why in this range we put plus, means positive side. We do the same for the x minus 2. We do the same. We look for the number in the range from minus infinity up to 2 exclusive. We can even take 0. If we take 0 minus 2, we will have negative 2, and we will see that we will have negative sign from minus infinity up to 2, and from 2 up to positive infinity. We will take any number as we did for the first factor. Sorry. If we take, for example, 3 minus 2, we get positive 1, and 1 is positive. You can take 5, 10, 11, and so on for your choice, and you will have positive. And for the signs for the 3x squared plus x minus 14, which is the product of the two first factors, we will multiply the signs. Minus for 3x plus 7 times minus for x minus 2, we will have positive. For in the range, the second range from minus infinity up, from minus 3 of from minus 7 over 3, sorry, up to positive 2, we take positive times minus, we get minus. In the next interval, plus times plus, we get plus. Dear friends, remember that we are asked to solve 3x squared plus x minus 14 less than 0. We look for where this 3x squared plus x minus 14 is less than 0. And we saw that when you have positive sign, means that it is greater than 0. When it is equal to 0, means that it is equal to 0. When you have negative, means that the left hand side is less than 0. And means that where 3x squared plus x minus 14 is less than 0, it is where we have negative. Thus the solution set, it will be from minus 7 over 3 up to 2 excluded. In this case we put excluded because we are given less than 0. We put included when you have or equal. When we don't have or equal, it means those numbers or boundaries will always be excluded. Thank you. We have another example which is different from the two first. Now we are given the inequality, which is looking like x plus 4 over 2x minus 1. This is not quadratic inequality, but knowing we cannot jump this kind of example because most of the time is challenging. In this case, it is slightly different from the two previous examples. In this case, we look for the numbers or the values which are making the numerator equal to 0, and we look for also the values which are making the denominator equal to 0. In this case, we take the numerator x plus 4 equal, when for x plus 4 equals to 0 means that x will solve for it and find that x will be equal to negative 4. For 2x minus 1 equals to 0, we will see that x there will be equal to 1 over 2. And in this case, we do the same as we did in the first two examples. We are going to make a table of sign. In this case, the first row, we put the values of x, and then, as usual, starting from minus infinity up to positive infinity, and here we have found minus 4 and 1 over 2. The 2 we put in the same row, in the same table, by starting as usual from the smallest number up to the largest one. Minus 4 is smaller than 1 over 2. That is why we start by minus 4. And the 2, the numerator and the denominator, those factors we put them in the table, starting from the numerator and the denominator comes next. I repeat, when you have this previously, when you have the product, we have to start to any factor, it is normal. But when you have the quotient like this, for example number 3, we have to start by the numerator, and the denominator comes in the row under the numerator. And for the last row, we put their quotient. And now we are going to look at the signs to be put there. For x plus 4, it will be equal to 0 when x is equal to negative 4. We put 0. And when x is equal to 1 over 2, the factor 2x minus 1, which is the denominator, will be equal to 0. And in this case, when x is equal to negative 4, the whole quotient will be equal to 0. That is why we put 0 in the column of x plus 4 over 2x minus 1. But when x is equal to 1 over 2, the denominator will be equal to 0, and x plus 4 over 2x minus 1 will not be defined. Will not be defined. It means that we will not put 0 as usual, but we will put the two signs, the smaller segment of lines showing that the x plus 4 over 2x minus 4 is not defined. And we are going to put the signs as we did for the first two examples. We look for the numbers in the range and we replace, then we will get the sign. For x plus 4, in the range of minus infinity up to minus 4, we will take any number. We can even take minus 5, minus 6. If we take, for example, minus 6 and replace by x, we have minus x plus 4, then you get minus 2. Means that that minus for minus 2 is the one that will be put there. And we will take any number between minus 4 up to positive infinity, as we did. Can take even 0, and then we will get positive. For 2x minus 1, we will do the same, and from minus infinity up to 1 over 2, if we, for example, we take 0, we'll have negative, and from 1 over 2 up to positive infinity, if we take, for example, 3 or 2 or 1, if we replace, we will have positive, the answer which is positive. And for the quotient of the two factors, we will take the sign for the numerator and we divide the sign for the denominator. Means that for the sign for x plus 4 over 2x minus 1, the first interval will take minus over minus. Remember that the product of the same signs will give you positive, and the quotient of the same signs always is positive. That is why minus over minus will get positive. In the second interval, we have plus over minus, remembering that the product of different or opposite signs will always negative, and the quotient of opposite signs always will be negative. That is why you have negative for the second interval, and positive over positive will have positive. And remember that the equation, the inequality which is given is x plus 4 over 2x minus 1 greater than or equal to 0, means that we will find where it is positive, and in those intervals they are the ones to be considered as where the solution set is. And finally, we will have a solution as from minus infinity up to negative for included, union from 1 over 2 excluded up to positive infinity excluded. Remembering that even though we have all equal sign, because for the value 1 over 2, it means the value which is making the denominator to be equal to 0, previously we said that that number is not a solution set. It will not belong in the solution set. We have another example, which is example 4, which is the last example. 3x plus 6 minus over minus x minus 1 greater than or equal to 0. Greater than or equal to 0. So in the solution we do the same. First of all, we find the value which is making the numerator equal to 0 and the value which is making the denominator equal to 0. They are found for the numerator. X is equal to minus 2, and for the denominator x is equal to minus 1. We put them in the table as we did previously. The first law is always containing the values of x starting from minus infinity up to positive infinity, and when putting the values of x which are found, always we start from the smallest to the largest. It is the rule. And we put those factors. Numerator is coming first, denominator it is next. Then we do the same as we did on putting the signs, and then we will see we'll have that 3x plus 6 will have minus, between minus infinity up to minus 2. Otherwise, in the other range, it is positive. For minus x minus 1, we choose any number between minus infinity and minus 1. Then we can take minus 3. And if we take minus 3, we will have minus 3, which is positive 3, minus 1, we will have positive 2, and that is why we have positive, and then in the other range after 0 we have negative. For the signs, for the quotient 3x plus 6 over minus x minus 1, we will take the signs, the quotient of the signs of the two factors in each interval, then we will find the signs that you can see here. Minus over plus, we get minus, plus over plus, we get plus, plus over minus, we get minus. And remember that the inequality is 3x plus 6 over minus x minus 1 greater than 0. In this case, we will see where this quotient is positive, and it is where it will be, we will have the solution. Means that the solution set will start from minus 2 excluded up to minus 1 excluded. Minus 2 is excluded because we have no equal or equal sign, and minus 1 it was excluded because even it would be excluded if also we don't have or equal. But simply the main reason here is that for minus 1, the given 3x plus 6 over minus x minus 1 is not defined. Note that we have some remark here. Some quadratic inequalities have no solution, and the others, their solution will be the set of all real numbers. In this case, we saw that when we are solving quadratic inequalities, we have first of all to factorize the left hand side. In this case, sometimes you can find that the left hand side, it cannot be factorized. In the other way, those ones who like to use the determinant in solving or factorizing, you will find that the determinant will be less than 0. In this case, remember, in solving quadratic equations, when you find that the determinant is less than 0, automatically we say that the given equation has no real solution. And when you are given to factorize any polynomial, you say that the polynomial is not factorizable. But in this case, we will not automatically conclude that the given inequality has no solution. We have to be attentive and to think critically. We are given two examples there. One example for each case. Solve the following inequality. We are given x squared plus 4 less than 0. If you try to use determinant, you will see that determinant will be equal to negative 16, which is less than 0. In this case, we think that if we try to replace any value by x, if we replace x by any value, we will see that if that number that you take, if it is put square, it will always be positive if it is a real number. And when added 4, it will continue to be positive. Means that you cannot get any number that you can replace x squared, and when added 4, you will get less than 0. Means that the answer always will be positive number. And you know that there is no positive value which is positive number which is less than 0. In this case, because the no value or no real number can verify that inequality, we conclude that the inequality has no solution. And finally, the solution set will be an empty set, a set of no element. And when, for example, number 2, we are given x square plus 9, which is greater than or equal to 0. And when you try to use the same way for the first example, by using the determinant, you will see that you will find that the determinant also will be negative, means less than 0. And if we try to think critically, every number or every real number which can be replaced by x, we will find that that number squared will be positive number. If added 9, you will get the positive answer. And when you get a positive number, always it is greater than or equal to 0. Means that every real number which can replace x, it will verify the inequality. Means that all real numbers for this case, they will be a solution. And finally, the solution set will be the set of all real numbers. Now, I have exercises or applications to see if you have well understood the lesson of today. I have 4 exercises or 4 applications solving the following inequalities. The first one is x minus 3 times x plus 3, which is greater than 0. We will find the solution. Secondly, we have 2x minus 6 over x plus 2 less than or equal to 0. Number 3, we have x squared plus 1 less than 0. Number 4, we have x squared plus 5 greater than or equal to 0. You are going to do it as a homework. Then I hope that you will do them successfully. And if every question has 2 marks, you will get 80 over 8. I wish you success. And this is the end of the lesson of today. We will meet next time. Thank you all. Thank you for your attention. Thank you.